Okay, this is a quiz preview for, well, quiz 6, sections 5.1 to 5.4. Graph each parabola, name the vertex, and sketch the axis of symmetry. Standard form for the equation, we use the vertex finder recipe or the axis of symmetry recipe, opposite of b over 2 times a. b is 2, so the opposite of 2 would be -2, and a is -1. So 2 times -1, we got -2 over -2, which is, of course, 1. So that's your axis of symmetry, x equals 1. The vertex will have this h value of 1. To find the y value that goes with it, we plug that in to the equation. The opposite of 2 times 1 squared plus 2 times 1 plus 4. That's going to give me -1 plus 2 plus 4, which is 5. So the vertex is at 1, 5. This parabola will open down because the a value is negative. A is -1. It will have a max then because it opens down. The focus recipe is h comma k plus 1 over 4 times a. That is the vertex value. So it's going to start with 1. The h part is 1. The k is a 5, so we have to do 5 plus 1 over 4 times a, and a is -1. That's going to be 5 plus -1/4, which is 4 3/4. You may write that as 1 comma 16, 17, 19/4, or 1/19/4. I don't really care which way you write it, but the directrix is found by doing k minus 1 over 4a, so that's going to be 5 minus -1/4, which is adding a fourth. So it's going to be y equals, it has to say y equals. That is an equation, and it's 5 1/4. Or you can say y equals 21/4. Domains -infinity to infinity, and the range is, well, let's check out where the vertex was. It's at 1, 5, and it's opening down. I'm going to do the 1 squared, 2 squared method. So you just have to take the a value of -1 times 1 squared. That would tell me to go, well, down 1, right 1, down 1, left 1. Then I'll do -1 times 2 squared. 2 squared is 4, so that's going to be -4. From the vertex, go down 1, 2, 3, 4, right 2, and down 1, 2, 3, 4, left 2. That's 5 points, which is fine. You could keep going if you wanted and do -1 times 3 squared, and that would make you go down 9 from the vertex and sketch your parabola. I'm not going to do down 9, right 3 right now, just time's sake. The range is going from -infinity up to the max point of 5. And it includes the 5. So you need a hard bracket on that, a soft bracket on your -infinity. Number 2 is in vertex form. The vertex form is y equals a times x minus h quantity squared plus k, where hk is your vertex. So I'm going to just jot down my vertex right now and put it in the right spot. That's going to be 1, -3. The axis of symmetry is the h value of the vertex, x equals 1. This parabola has an a value that's +2, so it's going to open up, which means it will have a minimum. The focus is, that's the directrix. The focus is found by doing -3, the k value, plus 1 over 4 times a. In this case, 1 over 4 times a is 2, so that's going to be -3 plus an eighth. You can type it on your calculator, but that's -2 and 7/8. The focus x value is 1, the h, and then -3 plus an eighth would be -2 and 7/8. The directrix is y equals k, which is -3 minus 1/8. Okay, so that's going to be y equals -3 and 1/8. Domain's still -infinity to infinity, and the range, well, let's see where that vertex was. 1, -3. Parabola opened up and had an a value of 2, so I'm going to do 2 times 1 squared, 2 times 2 squared method. I'm going up 1, right. Actually, I have to go up 2, right 1, because 2 times 1 squared is 2. 2 times 2 squared would be 8. Up 2, right 1, up 2, left 1, and then the next one, nice points, would be up 8. 1, 2, 3, 4, 5, 6, 7, 8, and right 2. Go back to your axis of symmetry, left 2. I think I forgot to graph the axis of symmetry on that last problem. Okay, so I will sketch in the axis of symmetry. I'm just going to do a dashed line. It's x equals 1 here. On the last problem, it was also x equals 1. Okay. And the third method, x-intercept form, which you want to set the factors, x plus 6 equals 0, x equals negative 6. That is a point on the parabola. It is the x-intercept. X minus 2 equals 0 gives us x is positive 2. So these are x-intercepts. Now, to find the vertex, you need to average those to find the axis of symmetry in between. Negative 6 plus 2 divided by 2 would be negative 4 divided by 2, which is negative 2. So your axis of symmetry is x equals negative 2. Okay, that's also the x value of the vertex. So put negative 2 in for h in your vertex. Now I'm going to pop negative 2 in there. 1/2 times negative 2 plus 6 times negative 2 minus 2. So I got to find the y value of the vertex. That's going to be 1/2 of 4 times negative 4. And that's half of negative 16, so that's going to be negative 8. So our vertex is at negative 2, negative 8. And then you can sketch your parabola. Chose to sketch it first this time. Okay. Now, if I asked you for the x-intercepts, you would write them in point form, which is negative 6, 0, and 2, 0. Those are ordered pairs. This thing's opening up, so it has a min. The focus is going to be negative 2 and then negative 8 plus 1 over 4a. A is 1/2. 4 times 1/2 is 2, so it's going to be, I don't know why I wrote equal sign there, negative 8 plus 1/2. And that's negative 7.5. The directrix is k, again, negative 8 minus 1/2, 1 over 4a. That's negative 8.5. Domain's negative infinity to infinity, and this one has a range of negative 8 to infinity. Oops, almost wrote an infinity symbol first. Needs to be negative 8, small to large, negative 8 to infinity. I just didn't want to write that on top of that y. I wrote a little big there. Next we have solve each equation by factoring. So this would be x plus 10 times x minus 2. And then you set each factor to 0. That will give you x equals negative 10. And the other one is positive 2. This one factors to 4x. It's a perfect square trinomial. 3 and 3. They're both negative. So you really only have one solution. This is a double root because there's 2 of the same factor. You would add 3, divide by 4, and get x 3/4. It is not plus or minus 3/4. This one would give you the same 0. So that's a double root. That means the parabola bounces at 3/4 on the x-axis. Number 6, I would divide everything by 3 to start. You always want to look for a common factor first. And then this factors to x minus 4 times x plus 2. Order doesn't matter on there. And then you set the 2 factors to 0 and get 4 for one of the answers or solutions, which are x-intercepts or roots. And the other is negative 2. This one is the difference of squares. 5x minus 7, 5x plus 7 is the factored form. Pen is sticking, sorry. So there are 2 solutions to this one. You get add 7, divide by 5, so x is going to be 7/5. And the other one, you subtract 7 and divide by 5, so x is going to be negative 7/5. Number 8, you want to set 0 first by subtracting 48 from both sides. That's going to give you, or actually we could, it says, oh, solve by square root. Oopsie, I was about to do solve by factoring. So I'm not going to solve by factoring because it says solve by square roots, and you must do the method that's requested. So add 8 to both sides, giving you 2x squared equals 56. Divide by 2, which is 28. And then x will equal plus or minus the square root of 28, which needs to be simplified to 2 times the square root of 7, because 28 is 4 times 7, and 4 is a perfect square. Number 9, you want to subtract 1 first. Giving you 3. Multiply by 5. X squared is 15. Take the square root, and don't forget it's positive or negative square root of 15. Number 10, we want to multiply both sides by 2 first, giving us x minus 3 quantity squared equals 16. Take the square root. Positive or negative square root of 16 is going to be plus or minus 4. Now, when you add 3, you're going to need to do positive 4 plus 3, which is 7, and negative 4 plus 3, which is negative 1, to get your 2 solutions. Now we have a height problem and an egg's being dropped. If something's being dropped, then you're using negative 16t squared plus the initial height. The initial height is h sub 0, that's 105, and it asks how long does it take for the egg to hit the ground. So when it hits the ground, the h value is 0. So I have 0 equals negative 16t squared plus 105. This can be done algebraically quite easily. Subtract 105. Divide by negative 16. So we're going to have to do the square root of, because it's t squared. Sorry, I'm going to put that up here. T squared equals 105 over 16. A negative divided by negative would be a positive. So we're going to do the square root of 105 divided by 16. We hit, get out of here. Clear. Second, x squared. And I'll get you the square root, 105 divided by 16. That is plus or minus, but in this case, it's about time, so we only want the positive answer. 2.56 to the nearest hundredths. 12, you are going to use the whole equation with the initial velocity in it. For this one, a tomato is tossed into the air. It leaves Brian's hand 4 feet above the ground. That's going to be h sub 0 is 4. Initial velocity of 35 feet per second. That's going to be your v sub 0. So, how long is the tomato in the air? Well, when it's not in the air, it's hitting the ground. The tomato misses her and lands on the ground. So height is 0, negative 16t squared plus 35t, I'm just filling in the formula, plus 4. Now we can use our grapher to find the answer to this, which would be much easier. It says how long, so we want to know the x-intercept. So we're going to be finding this value on the graph. Okay. The graph will extend that way, but we're not going to talk about negative time because time is the x-axis for this problem. So go to our y equals. I've already got negative 16x squared. See, but the initial velocity has changed, so I'm just going to adjust this equation. We had 35 for the initial velocity, and it was leaving the hand at, I'm going to just delete these, 4. Okay, I'm going to hit zoom 6 just to standardize my window and adjust it if needed. Oh, I got plenty of information I need to know. It's a little past 2 seconds, so I'm going to get it to the nearest hundreds by hitting second trace and calculating choice 2, the 0. I might get this intercept because my cursor is on the y-intercept, 0, 4. So I'm going to arrow it over a little bit before I try to ask it what I want to know. Okay, now that it's over here, I'm going to just hit enter. For the left bound, I can go past it and hit enter, or I can put in a number. So I'm going to just put in 3. Okay, and it went right on at 2.29. We're going to have to round that to 2.3 seconds. Okay, next, 2.30 if you wanted to be writing it to the hundredths place. Solve by graphing calculator. Oh, graphing on a calculator when needed, round to the nearest 0.001. So we're going to put the equation into y equals. Clear that one out. Put in 0.5 for 1/2 x squared minus 4x. Some parabolas do not cross the x-axis, but I believe this one does. Zoom 6 would be always a way to get back to a standard window. Okay, I want the x-intercepts. This one's between 0 and 1, so I'm going to hit second, trace, and for my value, I want to find the choice 2. I'm going to put in 0, enter, and 1, enter, because I know that first one's between 0 and 1. And then it tells me it's at 0.54. Okay, go back to my calculator, and I'll get the other 0. I'm going to hit second, trace, choice 2. And that's somewhere between, say, I don't know, 5 and 10. I give it 5, enter for my left bound, 10 for my right bound. Just giving some values that are in between. It is between, and it popped right onto it. 7.46, the nearest hundredth. Number 14, we're going back to the grapher. We're going to change the equation, but first we need to, oops, I didn't mention that. We need to set it to 0. 2x squared plus 12x plus 32 equals 0. You can divide by 2 here and reduce this equation down to x squared plus 6x plus 16. Regardless, you'll still get the same zeros. It won't matter if it's reduced or not, but it will look different. I'll go ahead and put it in as it started. 2x squared plus 12x plus 32. And graph. If you've typed in the reduced equation, this thing's going to look different. Now I'm not seeing anything, so I may have to adjust my window. So I'm going to try, I don't know, go a little wider, 20, and I'm going to try to go up higher. Oops. That parabola is opening up. Let's see if I just put in 20 for that one too, and then I'll hit graph again. So this parabola does not have any x-intercepts. I got to see it. So NA or none. Does not cross the x-axis. Area of a rectangle, you should know area is length times width or base times height. In this case, the base is 3x plus 15 and the height's x. We just need to multiply the dimensions that are labeled and set it equal to the area given, 42. Distributing x and subtracting 42 from both sides gives me an equation that is reducible by division by 3. So I'm going to reduce it down by dividing by 3. I'm just factoring out a 3. It's not going to change anything about the solutions. Let's see, that would be minus 14. Okay, x minus, it's going to be plus 7 times x minus 2. So one of the zeros is -7, the other is 2, which means, hey, this is the length of the side of a rectangle. I can't use the 7, so I'm going to say the dimensions, x is 2. So the dimensions, I guess I should have put my work there, but anyway, 2 meters by 3 times 2 plus 15 would be 6 plus 15 or 21 meters. Okay. Factor by grouping. Want to group the first 2 terms and the second 2 terms, see what they have in common. You can factor out a 4m, which would leave you with m plus p. Plus the second pair, you can factor out a 3p, which would leave you with m plus p. Now, the m plus p's are in common to these two ginormous terms, so I'm going to factor away from each of these the m plus 3p. And what would be left would be 4m plus 3p. So that's factoring by grouping. Group 2, factor out of 3x minus y, plus factor out of 2 from the second set, you get 3x minus y. Now I know I'm going fast, but I realize that you can pause if you need. The common term to these two big old terms is 3x minus y. Factor those out, and you'll be left with 3x plus 2. So if you multiply 3x by this entire 3x minus y all at once, then you would end up with this. This one you got to be careful with on 18, because if you put a parenthesis around these two, nothing changes. But if you put a parenthesis around 5x plus 20, you change the sign. So you have to change the sign of 20, because if you distribute the minus sign, you'll be back to what you started with. So there's a minus 1 out here. Now I'm going to factor what's in common, which is x squared. That'll be x minus 4 in parentheses. Here you have a 5 in common. So like I'm factoring out a minus 5. And I'll have left x minus 4. All right. So now the x minus 4 matches. Factor that away from each of those terms. You have left x squared minus 5. And I wouldn't care if the order's flopped. A lot of teachers actually do the x squared minus 5 first. That's not like how I prefer to explain it. All right, this says factor completely. So first factor out a common term of x times x squared minus 5x plus 4. Then factor the trinomial if possible. It's going to be x minus 4 times x plus minus 1. And that's fully factored. The next one is a difference of perfect squares. So that's going to be b minus 8a times b plus 8a. They have to be conjugates in order for the middle term to have dropped out. And there just happens to be a variable at the end as well. Now we're getting to simplifying the newest section, which involves I, the imaginary number I. And these are complex numbers because they have a real part and an imaginary part. So we're going to drop the parentheses on the second set, combining like terms. So I'll have 7, 5i minus 2ib plus 3i. That's pretty easy peasy. Now, this next one we're going to have to be careful because we have to distribute the minus sign. So it's going to be minus 13 plus 6i. 20 minus 13 would be 7, and 4i plus 6i would be 10i. Now we get a little more complicated because we got to distribute. So we got negative 9 plus 27i. Then I double distribute, plus 2i minus 6i squared. Careful about those I squareds. So 27i and the 2i we can add. We'll have negative 9 plus 29i. That's minus 6 times negative 1. We have to remember I squared is negative 1. Replace I squared with a negative 1 gives me a positive 6 here. So negative 9 plus 6 is negative 3. So in a plus bi form, standard form, a plus b times I, real part plus imaginary part. This would be your solution. And finally, the last two, we've got to multiply this denominator because you don't want complex or imaginary numbers in your basement. They're a little scary. So we're going to multiply by 3 minus I, the complex conjugate. 3 minus I, top and bottom, because what you do to the bottom, you must do to the top. So we got to FOIL out the numerator. 7 times 3, 21. 7 times negative I, negative 7i. Negative, so I did this. Now I'm doing this. Negative 6i next. And then last negative, a negative times negative, positive 2i squared. In the denominator, 3 times 3, 9. And then we get a negative 3i and a positive 3i. That's why we're multiplying by this. The conjugate makes that middle term drop. So we won't have any i's in our basement yet because I times negative I would be I minus I squared. And we know that I squared is negative 1. Replacing I squared with negative 1, we've got 21 minus 2. Okay. So 21 minus 2 is 19. And then we got minus 13i. And on the bottom, we've got 9 plus 1, so we get 10. If we rewrite it properly in a plus bi form, that's 19/10 minus 13/10 times I. And the bell is ringing. My class will be coming. Real quick, I'm going to tell you that. We're going to do I to the 24th by saying we know that I to the 4th power is 1. So there are 6 I to the 4th there. I to the 4th times 4 times 6 is 24. I'm using the power property of exponents. And I to the 4th is 1. So we got 1 to the 6th, which is 1. Now, if it had been I to the 23rd, then we would have I to the 3rd left over, which is negative I. Good luck on your quiz tomorrow.